Students voted correctly on this one as to which one was a volume calculation. Remember that a volume calculation of a prism is done by the area of the base times the height. In this case, the base is a triangle. How do I know that this is the base and it's not this one down here? Well, the base in a prism is if you stack a bunch of them all together, you get the entire shape. So if you stack a bunch of triangles together, you will get this shape. So this is the base. So the area of the base in this case is the area of a triangle, which is 1/2 base times height. And then the height of it looks like the length in this case, but that's going to be 10. So actually then your answer is B, 1/2 base times height times 10. And this will give you the volume. But what about the surface area? What will we do in this case? So what I have done here is we actually do not know the length of x, but I have labeled it anyway, and we can find it later. But just treat it as an unknown value for now. So most students did understand that if you wanted to find the surface area, that there were going to be two of the triangles like this. Now the sides of the triangles don't actually matter. What matters is the height and the base. So this is an isosceles triangle. This is 8, and then this is 6. And we have two of these. So 2 times 1/2 base times height. So it's either B or it's D, because there's going to be two triangles. And then when you think about the number of rectangular faces there are 3, but there's actually two varieties. There's the ones that are like 10 by X, and then there's the rectangles that are, well, the one that is 10 by 8. So it is actually possible to have 3 different types of triangles, or rectangles, but because both of these sides are X, there's only, this one's a duplicate, so 2 of these. So actually it must be this one, the one that has 2 of the 10 times X. So your answer is going to be D. That is the surface area of this rectangular prism. However, in order to do this, clearly, if you wanted an answer, you need actually the value of X. And we do not have the value of X, so how would you determine that? Most students did understand that you can find the value of X using Pythagorean. But the tricky part is, if you're going to find the value of X using Pythagorean, you need to have a right triangle, and this is not a right triangle. However, because it is isosceles, you can split it down the middle and make it a right triangle like so. If you do Pythagorean on that, you're going to get root of 52 over here as an exact value. And if you prefer to keep it as a decimal, you can, but you better keep 4 decimal places. Otherwise, your final answer might be rounded incorrectly. Once we know X, then we can determine the surface area. So this is the formula that was chosen from the previous page. If your calculator skills are very good, then you can plug it all in at the same time. So I'm just going to put 7.2111 in for X, and let's see what we get. There is one thing that we could clean up really quick here. If you're going to take 1/2 base times height here and you're going to multiply it by 2 anyway, then you don't have to write this, because 2 times 1/2 is just 1. So we don't have to punch that in. So when I type this in, I'm getting a final value of 272.222. So if you want to round that, because they've given it to the nearest whole number and they haven't told us if they want it to the nearest 10th, I'll just give it as 272. They have also not given us any units, but if you wanted to, you could put units squared. On an online assessment, be very careful. They will always tell you how they want you to round it. And so this would be the nearest whole number. So in this case, we have been given a cylinder, and I want to know which of these expressions is going to be what you type in if you want to find the volume. A cylinder is a prism, just like any other, which means that we can find the volume by taking the area of the base times the height. Just in this case, the base happens to be a circle. So the area of a circle is pi r squared. So r is the radius, and in this case it's 5, so pi times 5 squared. And then we can multiply by 20. So just be careful that you're not squaring the pi, you're actually squaring the radius. So this is going to be your volume. If you are typing this into your calculator, please use the pi button. Do not use 3.14. You may end up by off a decimal place, and on an online assessment that is going to cost you the entire mark. So find that button on your pi calculator, the pi button on your calculator. So again, surface area is a little bit more complicated. Which expression would be what you would type in to find the surface area? The surface area of a cylinder is a little bit complicated because we all understand that it's consisting of two circles. So the top and the bottom. So we are going to have this pi r squared, and we are going to need two of them, the top and the bottom. So we already know that the first part is the same no matter what. But then what about the part that wraps around? Like if this was a soup can, what would be the area of the label? What you have to remember about the label is that this unravels into a rectangle like this, but those green edges end up being the circumference of the circle because it wraps all the way around the circle, right? So the height of the label is going to be 20. And the circumference, how do you usually calculate the circumference of a circle? You got to think back to seventh grade where they're like, actually, the circumference of a circle is pi times the diameter or pi times 2 times the radius. So the diameter in this case is actually given. So this circumference here, the green line, is pi times 10. So 10 pi. And there is only one label. There are not two. If you unwrap it, it ends up being one long rectangle. So actually then, this is going to be the area of this rectangle, and there should only be one of them. So the answer is B. Okay, so for this one, they have given us a cylinder, they've given us the volume, and the radius, they have not given us the height. Can you determine the height? So in order to determine this, you need to know how to find the volume of a cylinder. So the volume of a cylinder is going to be the area of the base, or pi r squared, times the height. Now at this point, some students decide to start plugging in numbers. But I would really recommend that you isolate the variable you're looking for first, and that's going to be h. So I'm going to divide both sides by pi r squared and have h is equal to v over pi r squared. And now I can put the numbers in that I was given, and I can punch that into my calculator. And here's where a lot of things will go wrong. Big reminder, if you do not put brackets around the denominator when you plug this in or punch it in your calculator, it is going to come out incorrect. It's only going to divide by pi, and then it's going to multiply by 4 squared, and you don't want that. So please put brackets. So I'm getting a height of 1.989. If they want it to the nearest whole number, I would say 2 centimeters. And I know that this diagram is not at all to scale, but that's what I'm getting. Calculate the surface area of this box. Can you do it? If you can, think about the first few multiple choice questions and the way that I laid that out in one nice long statement, and see if you can maybe do it that way. It looks a little bit more elegant. Calculate the surface area. So there are three kinds of rectangles here. There's the 7 by 5 rectangle. There's the 2 by 5 rectangle. And there is the 7 by 2 rectangle. So there's three kinds of rectangles, and there are 6 of them in total because there's 2 of each. So 2 of these plus 2 of these plus 2 of those. So we are going to add those together. 118 meters squared. Okay, this one's quite tricky. They have given you the volume. They want you to find x, which is the length of the wedge. Can you do it? So first we need a formula of some kind. The volume of any prism is the area of the base times the height. And in this case, because the base is a triangle, the area of a triangle is 1/2 base times height, and then multiply by the height again. So I guess in this case, because this is the length, we'll call that length. So our particular volume is 1/2 base times height times x. And this base is the length of the base of the triangle, not the base of this, which is a little bit confusing. But I think most students understand this is the area of the triangle, and this is the length or the height of the box. So what might throw off a lot of students is the fact that this is a right triangle. And what does that mean in terms of the base and the height of the triangle? So if you want the area of this is the base, and this is the height. So what is 5? In this case, 5 is not relevant. It doesn't matter what 5 is. We have the base and the height of the triangle. So firstly, I'm going to isolate for x because that's how I do things. And then I will put in the values later. So first I'm going to multiply both sides by 2 to get rid of the 1/2. And then I'm going to divide both sides by base times height to isolate for x. So x is equal to 2 times the volume divided by the base and the height of the triangle. So 2 times the volume is 66, and I'm going to divide that by the base times the height. And when I type this in, I'm going to remember that if I don't put the bottom in brackets, we're going to get the wrong answer. The answer I'm getting out of my calculator is 11. Exactly. So what if we were asked to calculate the surface area of this prism? I find it really helpful to use colors so that I can highlight the different sides, different colors. So like this one is 5 is blue, 4 is green. This maybe I'll put like this, and then this measurement here is going to be purple. So in this case, the triangle that we have, we can calculate the surface area of the triangle by going 1/2 base times height. So 4 times 3. And there are 2 of those. So I'll multiply that by 2. But then when you think about the 3 faces, they're all actually different. So there are no duplicates. There's the 5 times 11 face, 5 times 11, blue and purple. And then there's the 3 times 5. Is there a 3 times 5 face? Yes, there is. Actually, I don't think that there is a 3 times 5 face. So this face, the blue and purple face, and then there's the the purple and green one. So I will go to the purple and green one instead. So the purple is 11 times the green is 4. And then this back face here is purple and red. So 11 and 3. And those are the 3 faces. So there is no face that backs the red onto the blue. So just be careful with that. And then we're going to add all these values together. Let's see what we get. I can already see that this 2 cancels out with this 2. So it's just 4 times 3. I'm getting a final answer of 144 centimeters squared. This is a question that a student asked about how to deal with scale factors. So let's suppose that a map is drawn at a scale. Let's make it a really weird scale of like 3 centimeters to, I don't know, 70 kilometers, let's say. So 3 centimeters on the map is 70 kilometers in real life. So how far is in real life is 6.5. Actually, we'll make it an even weirder number. Let's make it 10.25 centimeters on the map. So this question can actually be done with proportional reasoning because we have a scale factor. We have 3 centimeters is equal to 70 kilometers. And we want to know 10.25 centimeters is equal to how many kilometers? That's our x. So if you think back to our proportional reasoning questions, you have to put the kilometers in the top and the centimeters in the bottom, or vice versa. But the reason why I've chosen to put the 2 kilometers in the top is because the unknown is in the top. And that's going to be a lot easier for us to deal with. So we have centimeters in the bottom, kilometers in the top. You could have done it the other way around. Like you could do it like this as well. That's totally fine. It's just a little bit tougher to solve this one. So that's why I've chosen to do it this way. So if I do that, then I can multiply both sides by 10.25 to try and get x by itself. So 70 times 10.25 and then divided by 3. And I'm getting x is equal to 239 kilometers on the map.